Part of our work in using Laplace transforms to solve differential equations is to find the Laplace transform of various functions. We saw earlier that the Laplace transform of y of t equals sine alpha t is given by alpha over s squared plus alpha squared. Now we can find the Laplace transform of cosine alpha t in a similar fashion. But recall that it required integration by parts twice and it was a messy calculation. Instead, what we'll do here is use what we know about the Laplace transform of sine alpha t to find the Laplace transform of cosine alpha t in a clever way. What we'll do is come up with a differential equation whose solution we know. In particular, we'll use that for y of t equal to sine alpha t, it's a solution to the differential equation y prime equals alpha times cosine alpha t, since this is the derivative of our function y here. Also, with this function y, we know our initial condition y of 0 is sine of alpha times 0, which is sine of 0, which is 0. Now we have an initial value problem whose solution we know. We'll come back to this in a moment. For now, let's try to solve this differential equation using our method of Laplace transforms. So we'll take the Laplace transform of both sides, giving us the Laplace transform of y prime equals the Laplace transform of alpha times cosine alpha t. On the right, since alpha is a constant, we can pull it out of the Laplace transform and write it as alpha times the Laplace transform of cosine of alpha t. On the left, we know the Laplace transform of y prime can be written as s times the Laplace transform of y minus y of 0. But y of 0 is just 0, and the Laplace transform of y is the Laplace transform of sine alpha t, since that's our function y, which is alpha over s squared plus alpha squared. So on the left, we have s times alpha over s squared plus alpha squared. And this leaves us with the equation s times alpha over s squared plus alpha squared is equal to alpha times the Laplace transform of cosine alpha t. Now remember, our whole goal here was to figure out what the Laplace transform of cosine alpha t was. But we can get this by solving our algebraic equation for the Laplace transform of cosine alpha t by simply dividing by alpha. And that will leave us with the Laplace transform of cosine alpha t is s over s squared plus alpha squared. So we now know how to find the Laplace transform of both sine alpha t and cosine alpha t.